So, in this present series of artificial intelligence, in the previous lecture we looked into propositional logic, and we have also seen that first order predicate logic or predicate logic is actually an extension of propositional logic. So, our today's main agenda will be kind of surrounded around first order logic, which is FOL, and also we are going to cover some of the leftovers of the propositional logic also. You remember in propositional logic in the last lecture we have looked into connectives, what kind of connectives I am talking about. So, let us say there is a atomic proposition, and in order to connect the two or kind of multiple atomic propositions, we use logical connectives. What of those logical connectives? They were and, not, or, if then, if and only if, and so on and so forth. So, we have seen those logical connectives, we have seen the equivalence rules and characteristics and properties of prepositions. Today what we are going to look into is precedence of these connectives while working with propositional logic statements. So, when we evaluate some compound prepositions and these compound prepositions are having multiple logical connectives, it is important to follow a specific order of precedence in order to come up with the accurate results. And this is actually very similar to the arithmetic operations, in which the the logical operators or the kind of simply we can say some mathematical operators are also evaluated in a defined sequence. So, for example, your multiplication is having a higher precedence as compared to the addition. So, here also the logical operators which we are going to use, or these logical connectives which I am talking about, they are defined, they have a definite precedence from highest to lowest. And what is this precedence and how is this precedence going to affect the whole conclusion, the whole computation? Let us see that. So, first of all, look into the we will look into the order of precedence. So, order of precedence is the first is not, which is the negation, which is having the highest precedence and is evaluated first. It is followed by conjunction, which is and evaluated next after all the negations are resolved. Then comes in the race is disjunction, which comes after AND operations. It is followed by if then, which is nothing but implication, that is evaluated after OR, and then finally we have if and only if, which is the biconditional or double implication, and that is having a lowest precedence. So, from highest to lowest it is not, and, or, if then, and if and only if. Now, let us take a very small example in order to see how are we going to kind of resolve it. So, for example, we have a proposition which says negation of P or, within the bracket we have Q and or. So, first of all, negation of P is evaluated, and also whatever is within the bracket is evaluated first, which is Q and or. And then finally the or, which is the or connective between negation of P and it is connecting Q and or, these two, it is connecting these two components, will be evaluated, and the final result will depends on the proper evaluation order, which is going to ensure the correct outcome. If the proper evaluation order is not kind of we can say followed, then the outcome could be it's a higher possibility that your outcome is going to be incorrect. Now, when we started with the propositional logic, we looked into propositional logic, and then with a very small or with a very brief difference, I made you understand that what is the difference between propositional logic and predicate logic. With that foundation already built in, we also need to look into some of the kind of other types of logics in AI. So, before going into the predicate logic in detail, let us try to understand what all are the types of logic in AI. So, propositional logic we have already seen. This is often known as sequential or zeroth order logic, and it actually constitutes a fundamental aspect of logical reasoning. within the realm of AI. And in this topic we are also going to look into in which kind of scenarios what kind of prepositions will be formed and how it is going to be different from the predicate logic or all other examples of AI or all other types of logic in AI. So, in its essence, if we talk about the prepositional logic, this is the logic that deals with prepositions, statements, and every prepositions and statement is having a truth value assigned to it, which could be either true or false, and this actually gives you as the values are just true and false, this gives you a simplistic binary framework for decision making. So, now let us take an example that there is an AI system whose task is to optimize the performance of a renewable energy system, let us say maybe a solar farm or kind of a windmill kind of something. So, in the context of prepositional logic, the AI could formulate the prepositions like sunlight density is above a certain threshold, it could be kind of true or false, or it could say kind of wind speed is within the optimal range, and then there is an optimal range which is already defined. So, these kind of prepositions will be having either the value true or false, and by formulating these prepositions, by looking into the truth value of these prepositions, your AI system will take the help of prepositional logic in order to kind of function, in order to implement its functionality. Now, these kind of prepositions, say for example, sunlight density is above a certain threshold or wind speed is within the optimal range, these become pivotal elements in AI's decision making process, and with these prepositions, actions of adjusting the solar panel angles or regulating the wind turbine is going to be kind of determined, and the output will be based on the assessed truth values. Now, this was a very simple example of the prepositional logic, and in the previous lecture also we have looked into what prepositional logic is in very detail. Now, moving further one step, let us arrive at first order logic. So, first order logic, as I have already told you that it is the extension of prepositional logic. It is going to introduce notion of variables and quantifiers into the prepositional logic, and hence it is known as an extension. By this extension, it will bring a more nuanced layer of complexity to the logical reasoning, and yes, we are going to look into the example of the first order logic from the similar kind of perspective which we have seen from the similar example which we have just seen. So, in the first order logic system, statements are not merely true or false, they also involve some properties, some relationships, maybe some objects on which they are going to be applied with the help of quantifiers. We can also achieve that. So, let us try to understand that with the help of the similar example. So, we have that AI task which is having AI system which is tasked with the managing a complex network of renewable energy assets, and we have deployed first order logic in order to enable this AI system to express some intricate relationships, such as for every solar panel there exists a corresponding battery. So, for every or for all we can say, and then the term is there exists. So, for every solar panel there exists a corresponding battery. If we want to kind of depict this thing into prepositional logic, we won't be able to do it because we don't have any quantifiers for all and there exist. Also, let us say if the wind speed exceeds a certain threshold, decrease the rotational turbine of rotational speed of all turbines. So, for example, these kinds of when we say all decrease the rotational speed of all turbines. So, this kind of expressiveness is not available in prepositional logic, and here in first order logic it allows the AI to model and comprehend the interconnected aspect of renewable energy system, which ultimately facilitate more sophisticated decision making and optimization strategies obviously. So, these were the two terms which we were kind of already familiar, that is prepositional logic and FOL, which is first order logic, or we can say first order predicate logic. Now moving on to the next type of logic in AI, which we have not kind of even discussed till now, is actually the fuzzy logic. So fuzzy logic is something which is going to take you away from the binary nature of the classical logic, and it also acknowledges the shades of grey or the grey area between true and false, and hence in this way it allows a more nuanced representation of uncertainty. So, in AI applications, let us say for renewable energy, the example which we have taken for propositional and FOL, fuzzy logic proves kind of valuable in handling imprecise and fluctuating inputs such as weather conditions. So, when we look into the weather conditions, this is something which is kind of we can say imprecise, and also the input is going to be kind of vary a lot. So, imagine the AI system which is responsible for managing that solar plant which we were talking about. Instead of categorizing sunlight as either completely present or completely absent, there could be kind of an hazy day in which yes, there is a sunlight, but kind of it is having the light is available with a little kind of less intensity or with more intensity. So, fuzzy logic here allows the AI to assess various degrees of sunlight intensity. This flexibility empowers the AI to make again more complex, more sophisticated decisions, like adjusting the energy production in response to varying cloud covers. So, for example, we say here the fuzzy logic's availability is to capture and process the uncertainties is definitely going to enhance the adaptability of AI system in the dynamic context of renewable energy operations. So, for example, let us say we say if the sunlight is kind of dim, or we can say the sunlight is having the high intensity or something of that sort. So, this dim or kind of a little higher or the high intensity, these are the terms which can be kind of we can say easily captured or easily expressed with the help of fuzzy logic. So, because it is not like the kind of complete absence or presence of the sunlight, we are not talking here in terms of binary logic, we are not talking here in terms of 0 and 1. Here we are talking okay, it is present but the intensity is less, or maybe it is absent, it is present but with a higher intensity. So, here in order to capture these kinds of complexities or these kinds of uncertainties in the system and to enhance the adaptability of AI systems, we need fuzzy logic here. So, we have seen propositional logic, we have also looked into kind of some kind of FOL, which is first order logic. We also try to understand what is we also try to understand that what is fuzzy logic. Moving further in the types of logic used in AI, we have the fourth one, which is model logic. So, model logic introduces, as the name indicates, introduces modalities or qualifiers to classical logics in order to kind of cater to different states of affairs or possibilities. So, modalities are expressions that signify necessity, possibility, belief or time. In the realm of AI and renewable energy, this model logic finds relevance in scenario planning and decision making under different conditions. So, here we can also use this model logic. Let us take the similar example where your AI system is managing a wind farm rather than the solar farm here. So, model logic allows the AI to reason about various possibilities such as different wind speeds, then the turbine states according to them, and the maintenance scenarios. And this kind of we can say the sophisticated approach leveraging modalities enables the AI to make decisions that consider not only the current state, but also the potential future states, contributes to improved forecasting and adaptive strategies. And by also by incorporating these kinds of model logics, AI systems in renewable energy will be able to enhance their extend their capacity to anticipate and respond to a wide spectrum of the operational scenarios. So, propositional logic, first order logic, fuzzy logic, and then we have model logic. Moving further, we also have Bayesian logic, which is kind of the Bayesian logic. The moment we say Bayesian logic, and the very next moment we remember of probability theory. Why? Because Bayesian logic, we can say, is deeply rooted in probability theory. Actually is a cornerstone in AI for decision making under uncertainty. And when I am saying Bayesian logic, it actually applies Bayesian theorem to update the probabilities as the new information emerges. So, whenever you are going to add something, some new information is going to be kind of what we can say, it's going to be incorporated into the knowledge base. The Bayes theorem will be will keep on updating the probabilities. So, in the context of these renewable energy systems, Bayesian logic proves invaluable for predictive maintenance. Again, similar situation, imagine AI driven solar farm management system. Bayesian logic allows the system to continually refine its predictions about potential faults or the performance issues based on the incoming data. So, for instance, if a solar panel shows a slight degradation in performance, the system, leveraging Bayesian's principle, can intelligently update the probability of an impending failure. So, here when we need to look into the probability of an upcoming event, your Bayesian idea or the Bayesian principles are going to be used here, we can say. And these kind of dynamic adjustments enhances the precisions of definitely the maintenance schedules. It also ensures timely interventions and optimize the overall performance of that solar system. And by incorporating these Bayesian logic, AI model in renewable energy seamlessly adapt to the evolving conditions, offering more reliable and efficient operations. So, for all the logics, propositional, first order, then fuzzy, then model and the Bayesian, I have given you the examples related to the AI systems or related to the AI agents who are maintaining this renewable energy farms. So, this is kind of one example, but you can have many others. Now, with this when we are aware of all the types of logic which can be used in AI, propositional logic, out of them we have covered in detail. Let us move on to the first order logic, which is more commonly known as FOL, also known as predicate logic. It helps us to represent knowledge, reason through problems and understanding language, and we have also seen kind of couple of examples, some in the previous lectures, and this solar energy farm or renewable energy farms example we have just seen. So, by building on the propositional logic, as it is an extension of the propositional logic, and by adding quantifiers and predicates, this first order logic allows us to express more complex relationships and make decisions based on the logical reasoning. And this first order logic makes it as an important part of how we create our intelligent system that can reason and interact with the world in a completely meaningful way. It is used in many fields, including you must have seen this in the mathematics, like this is an integral part of the discrete mathematics courses. Then obviously in the philosophy it is there, then you have linguistics, and definitely computer science is something it's such a field which is going to use this FOL under the umbrella of AI. Now, when we say that this first order logic is actually a extension of the propositional logic, it introduces some kind of new we can say entities here, which are nothing but quantifiers and predicates, and because of these quantifiers and predicates, your FOL has become kind of more expressive, more versatile. So, in order to look into all the key components in a comprehensive manner, all the key components of the first order logic in a comprehensive manner, let us look what is the list of these. Constants, some specific objects or entities, for example, May, June, to New York, Elise, Bob, and something of these sort. These are actually the constants. Then comes variables. They stand for unspecified objects or entities. For example, anything x, y, z which may have any value in the due course of action, and it will change its value, is nothing but the variable. Then we have predicate. These are actually kind of defining, this is actually defining properties or relationships. So, for example, let us say I want to write Alice likes Bob. So, I will say likes, then the first parameter within this is going to be Elise and the next parameter is going to be Bob. So, in this way we can define properties or relationships between the objects or between the variables or between the constants. So, for example, I am writing father and within the bracket I am writing x comma y. So, x is the father of y. This is also a way of defining the relationship. Apart from constants, variables and predicates, we have functions. So, for example, these functions map the objects to other objects. So, for example, mother of x refers to an x variable who is having some other entity as mother. Then we have quantifier, basically to define, these are used to define the scope of the variable. So, within the quantifiers we have two, as you are aware. One is the universal quantifier which is for all, and it applies a predicate to all the elements. So, for example, if I am going to say for all x within the bracket it is having person x implies mortal x, means all persons are mortal, and this predicate is actually applying to all the persons because we have written for all x. So, all persons are mortal. Then we have existential quantifier which says that the predicate is applying to some, or we can say it shows that the existence of at least one element is there, if not more. So, for example, I am saying there exists x within the bracket person x and likes x comma ice cream, means someone likes ice cream. So, that someone could be either one or more than one, but here we are not claiming that all persons like ice cream because we have not written for all x. So, if there is kind of existential quantifier which is denoted by an inverted e, that shows the existence of at least one element, and for there exists x within the bracket person x and likes x comma ice cream, means someone likes ice cream. Apart from that, we have already seen the logical connectives which were there in the prepositional logic, and here also we have them. We have conjunction, disjunction, implication, and double implication and negation also. So, all those kind of logical connectives are available here as well. Then we have in order to look into the utility of first order logic, we also need to see that how what are the how are we going to deal with the syntax and semantics of FOL. So, FOL syntax define how to construct valid logical expressions, because syntax is also syntax is always related to writing the expressions correctly as per the rules of the grammar, while semantics, it always gives meanings to those expressions based on the based on any kind of interpretation. And now this interpretation is actually, interpretation provides a domain of discourse and assigns some meanings to the constants, predicate and functions too. For example, consider the domain of natural numbers, and then there is a predicate which says greater than x comma y, and this is kind of saying x is greater than y, or we can say that this predicate holds if x is greater than y. So, if x is equals to y and if x is equals to 5 and y is equals to 3, then we can say greater than 5 comma 3 is true, or if the values are opposite, that means the x is equals to 3 and y is equals to 5, then this greater than x comma y does not holds true, that means it is false. So, basically kind of syntax and semantics of first order logic if we talk about, so that is under a domain of discourse. So, here that domain is the domain of natural numbers, and if they are written kind of syntactically correct, then within the domain of discourse we can look into their meanings, and by the interpretation of their meaning we may assign or we should assign one truth value to them. So, either it is true or what we can say is false. So, in this lecture what we have looked into is we have seen the order of precedence of these logical connectives with reference to the propositional logic. Then we looked into what all types of logics are available in AI, and switching on to the greater details of first order logic, we have also looked into kind of what all the what are the key components of first order logic. Then we also understood the syntax and semantics of the first order logic, but much is to be covered in this the subtopic of FOL. Here is a list of references which is being used for the preparation of lecture with new discussions of first order logic. I will see you in the next lecture. Till then, take care. Goodbye.